this is not on our same network. So the destination MAC is going to be 0168. Very important to understand. Knowing this power, you can send traffic anywhere you want just by changing the destination MAC address. And that switch will forward that data based on it. So now this traffic, what does it do? Goes through the switch. The switch looks at it and says, oh, you have a destination MAC address of 0168. That sits on this. I'm going to bring you over to here. This router gets it, opens it up, the layer 2 information, says that's from me, removes it, looks at the layer 3 information, and says, oh, okay, well, that goes out this interface. So now he has to rebuild this information. Rebuild it, yes. When information comes into the router, we don't just forward it on. We have to rebuild the source, destination IP, and source and MAC. So what's the source IP going to be? Remember what happens when you have a source IP coming over to PC2 or PC8. PC8 is going to change that information to its own. And I said that correctly, just not 100% clear. So here I have a source IP. This is 192.168.1.1. This is 192.200.200.8. Source IP 1.1, destination IP 200.8. So far, so good. Don't worry about the source of MAC. We're talking about layer 3 now. So when that traffic comes over here, PC is going to say, okay, this traffic was sourced by 192.168.1.1, and it was destined for 192.200.200.8. Now, PC2 is going to say, all right, I understand this. Now, whenever I need to send traffic back for this particular, when I need to send traffic back to 192.168.1.1, what am I going to do? I'm going to put that as my destination IP. And now the source is going to be me. Very important to understand, especially when I'm doing a ping request. I'm going to send the ping this way, saying, hey, I'm expecting an accurate reply. Because it was sourced by 192.168.1.1, he knows that that information needs to be destined for 192.168.1.1. And his source IP will be himself. And he will send that traffic back over here. So if I have a router here and I say, okay, well, we're sourcing it from 192.200.200.10, then my destination over here will be what? 192.200.200.10. Well, that doesn't make any sense because then it's going to go to the router. And then the router is going to say, oh, that belongs to me. Let me open it up. And it goes no farther. So how do you get back here? Well, apparently the router has to make sure that the source information remains the same when he is rebuilding this information. There's no reason for him to change the source IP. And what about the destination IP? Remember, if we change that, it'll never get to his destination. So that must be the same as well. Now, what about the source MAC? Well, that's a funny thing, because remember I told you that as I showed you with those IPs, that those MAC, those ARP tables are only for the local network? Haha. Well, that means something, because if it's for the local network only, 192.168.1.10 is not on the same network as 192.200.200.10. So how are we going to do this? Because PC8 will never have this MAC address in here, but he can have this one. So we're going to change the source MAC address to my own, which will be 192.200.200.10. And of course, the destination MAC is going to be going to this PC. So that means the source IP and the destination IP never changes, which makes sense, because this is layer 3 information that we need to get from point A to point B. And if we make any changes to this whatsoever in our transit path from point A to point B, and of course this will be my transit path. My transit path will be going to here, to here, to here. This all in transit. Think of a transit path as all the things that you do or pass as you're going down the street. Now, if I had to come through here, and this was a decision point of where to go, you see my point? And let's call this Apple Cider Street. We'll say it's on a different road. Somewhere it changed. Doesn't really matter, but this is a decision that we have to make. We got several places to go. We can go in this direction, or we can go in this direction. So we have to make a decision. And at this point, this is a decision maker. So I'm going to decide to go straight from this point. And I'm going to go straight. Here's another decision maker. Okay? And I'm going to decide to go straight. And here's another decision maker. I'm going to have to go straight. So, guys, these are routers. Every time you're driving, you're making routing decisions. And you didn't even know it. You're making these decisions. You are the router every time you come to this point. Here's router 1. Here's router 2. Here's router 3. And every one of these are your transit path. Every time you're sitting at a traffic light, every time you need to turn, every time you need to make an exit, you are transiting it a router. That's exactly what you're doing. So this is your transit path. So when someone says, what's your transit path? Oh, I had to go through, and what do we call these? Intersections. I had to go through Apple, Elm Avenue. I had to transit through Apple, Tree Street, and I had to transit through Apple, Plum Street. And there's your transit path. So when you're going through your transit path, if you change the source and destination of those IP addresses, well, you're gonna find your traffic not going where it belongs. So why do this? You wouldn't. So the router makes the decision of saying that I'm going to change the source MAC address, though, and the destination MAC address information. This will make sense because on this side, we'll never know anything about on this side. Very important to understand. Let's take a look at what our layer 2 information is and where we're forwarding at layer 3. Here's our layer 2, layer 2, layer 2, and right here is when we're making a forwarded decision via layer 3. Okay? So let's take a look at it like this again. Router 1, here's PC 1. Here's PC 1. Here's router 1. Here's router 2. Here's router 3. Here's router 4. And here's router 5. And here is PC 2. 192.168.1.1, 192.200.200.8. PC 1 trying to communicate 192.168.1.2. He's going to have a source IP of 1.1, a destination IP of 200.200 or 200.8. Now, because this should never change, we should know no matter where we see this data, before it gets to PC2, it should have the same source and same destination, no matter where we see it. But because this is layer 2 information, this is layer 2 information. What about between here? These two routers. Layer 2, layer 2, layer 2, layer 2. These might be IP addresses that we're sitting on, and we might be making 40 decisions of going out. But these two still have MAC addresses. And if they still have MAC addresses, they're going to be sending that traffic via what? Think about that. We're going to have the source as it's leaving this interface. We're going to have the source IP and the destination IP. But the source and destination IP is for what traffic? We're forwarding somebody else's traffic. This source and destination is for this traffic. The only way we can move the traffic is via the source MAC and destination MAC. Which means we, going from router to router, we are using the layer 3 information that we never change to make our forwarding decision, but we are moving it via layer 2, going into this interface and coming over to here. I know it sounds kind of weird, but remember, these informations here, the source and destination MAC addresses, they're going to change every time. So I'm going to have a source and MAC address of 11 to 168. Is that what we had? 168 going to here. Then I'm going to change that for my source MAC address. Maybe it's 169 and send it over here to 170 because that's the MAC address of here, 170. Then I need to forward that. I'm going to change the source MAC address to 180 and make the destination to 181. That's why it goes out here. Now, this is a point-to-point link, which we'll discuss later on. If that's point-to-point, then that makes sense. That it doesn't really matter. It's just, whatever we send out here this is going to get it anyway. But we still have to have the layer 2 information, because how does the PC know it's actually for him on the router? So every time we go through here, every time, we're going to have a different source MAC and destination MAC. This will be one source MAC and destination MAC. This will be different. This will be different. This will be different. So let's go through this again. One more time. This will be a particular source and MAC address. Source and destination. That information will change when it's leaving this router. When it's coming into this router, it will be whatever it left this router. Then, as we're sending it out this, the source and MAC address will change. And this keeps happening, which means no matter where I'm at, I'm going to have a different MAC address coming from here to here, source and destination MAC address, than it is going from here to here. Very important to know. So this basic communication seemed to become somewhat complicated. So we know all these MAC addresses now. So as I'm building this, I'm going to have a source IP of 1.1, destination IP of 200.8. I'm going to have a source MAC of 1111, destination MAC of default gateway, right? Because it's outside of my network. And that's going to be 0168. Now, when router 1 goes and resends that information out, he is going to have a source IP address of 1.1, a destination IP address of 200.8, the source MAC of 1111. Really? No. Remember, it was sourced from PC1 in this perspective, coming in this interface. But when I need to leave out this interface, 1111 is not on this segment. So now I have to replace this source MAC address with my MAC address of this interface because it's on the same network as this one. So now the source MAC address is going to be 0200 because there's our 200. That's what we made it, right? And our destination MAC will be 8888. So if I would have asked you, leave as the packet is leaving router 1, tell me what the source MAC address and the destination MAC address and the source IP and the destination IP would be, you would have this information. This is all you would have. This is all you would have. And I would write your question and say, packet's leaving this interface. What's the source and destination MAC? And I'll just give you a bunch of IP addresses. I mean, a bunch of answers, which will have the source and destination IP and the source and destination MAC. And you, off the top of your head, should be able to do this within a minute. In less than a minute. You know why? Because you know the source, the MAC addresses will always change, and you know the source IP addresses never will. I mean, the source and destination IP addresses never will. And the source and destination MACs will always change hop by hop. The second that I'm going to be leaving my network, those MAC addresses, source and destination, are going to change. And that is pretty much it with our explanation of basic communication. It's very crucial to understand this because basic communication is how all our PCs, routers, and switches communicate. Remember, we might be learning routers and switches, but what's connected to those routers and switches? PCs. So we want to know how that traffic comes from the PC, comes into our router, how the router communicates with the host, and sends that traffic on. And this is pretty much our basic understanding of communication.